And once again, and welcome to yet another lesson. Now, today I want us to talk about the pneumatic governor that is used in diesel engines. In this session, we are hoping to explain the function of a pneumatic governor. We're also going to identify the key components of the pneumatic governor, describe how it controls engine speed, and then probably discuss its advantages and disadvantages. And lastly, we're trying to see the typical applications of this governor. So maybe just to do a recap and remind ourselves that a governor regulates engine speed within the set limits despite the varying loads. And you say that it's very important in the diesel engine that the speed is regulated, that the engine will not self-destruct as its components are quite heavy. And in the reciprocating engine, if the engine is allowed to run in itself, it may run faster than expected. So the types that we have seen the mechanical governor, which is a centrifugal governor. We have seen the hydraulic governor and its application in the DPA pump. And now we had left out this part of the pneumatic governor, which we're going to look at its application in an inline injector pump. So then why use a pneumatic governor? If we say, one is that it is simple in design and low cost. It's a very small unit, as we're going to see much later. And two is that it's common in small to medium diesel engines, and it uses a pressure difference to adjust fuel supply. So it is fully automatic and depends on the pressure generated at the engine. And lastly, it will automatically maintain engine speed. So I'd like us to look at the main parts of this engine. This governor has two main parts. One, what we call the diaphragm unit, which is found in the engine in the intake manifold. As you can see here, we have our intake manifold coming inside here, and in the inside manifold we have a butterfly valve similar to the one you see in petrol engines. And then we have the second unit, which is called the diaphragm unit, which is attached to the rear of the inline injector pump and has a push rod attached to a diaphragm that actuates the pump rack. So it's good to note that this engine does not have a mechanical connection to the injector pump. Rather, the accelerator pedal operates the throttle valve. As you can see, this linkage here, pedal is linked directly to the throttle valve, just like a petrol engine. So when the throttle is closed, then the diffraction is carried by this orange pipe here to the diaphragm unit and communicated, and therefore the diaphragm responds accordingly. So it's good to know that this diagram may not show here clearly, but we actually have a venturi, form of venturi here in the middle here. Now on the other side of the pump, we can see the linkage to the fuel rack. This is a pump, and this is a linkage to the fuel rack. And you see that the fuel rack uses the rack and pinion mechanism to turn all the pumping elements, that is the plungers, to reduce or increase the amount of fuel that is delivered by the delivery valves. Now on this other hand, we have now the diaphragm unit. So one side of the diaphragm is exposed to atmospheric pressure, and the other side is exposed to the vacuum that is generated at the venturi in the engine. And then of course you have a control spring that tries to push the rack back to the maximum fuel position. So anytime there's no depression, this control spring pushes the rack all the way to the end to make sure that the plungers are at their maximum to deliver maximum engine speed. Now, the operating principle is that we talked of pressure difference. So this governor will use the airflow from the engine intake manifold And as the throttle flap is closed and open, then the airflow varies, and this changes the depression that is created in the venturi unit. So it is this air pressure difference that acts on the diaphragm that is connected to the control rack. And then this one controls the amount of fuel injected to stabilize the speed. So let us look in depth and see how this actually operates. So for example, when we start this engine over, we say that the pump rack has been pushed to the maximum by return spring. And during this time, the driver will want to operate the accelerator pedal so the engine can start faster. So he'll open the throttle completely and then turn the engine over. Once the engine fires, he releases the accelerator pedal, and this closes the throttle valve. Once the throttle valve closes, it means that the air is now struggling to pass through. As the pistons are moving up and down, sucking air into the engine, the air is struggling to pass through the depression. Therefore, we have a higher depression. This depression then acts on the pump rack and retracts the pump rack to give us the minimum fuel for idle. Now, as the engine speed increases, the throttle valve is opened gradually, and therefore the vacuum that was there now starts to decrease, or the vacuum that was being decreased starts to collapse gradually. And as this happens, it means that now the return spring overcomes the force generated by the depression, and at any given speed, the position of the rack is as a result of an equilibrium created by the spring tension and the depression created at that speed. So this continues through that speed range until to a point when the driver tries to do maximum speeds and is depressing on the accelerator pedal flat out. This opens the throttle to open fully, and this means that the depression has now almost collapsed. But again, due to the venturi, the airspeed passing over the venturi now creates a new type of depression, and this depression now acts on the vacuum unit and therefore retracts the pump rack backwards to reduce the maximum fuel, or to reduce the fuel and therefore reduce the fuel that is being consumed. So in this cycle, we see that if for any reason we are doing constant speeds and the load decreases, say the gradient of the road changes, the speeds tends to increase, and then this creates a stronger vacuum because the pistons are moving faster, and therefore the increased vacuum moves the diaphragm backwards, and the diaphragm moves the linkage to reduce the fuel supply. And then engine speed drops to the set point, and this cycle continues. If the opposite was to happen, if the load was to increase and the speed reduces, then that means that the depression would now reduce, and this would cause the vacuum to reduce as well, and the spring tension would take place and now move the diaphragm together with the linkage to increase fuel by turning the fuel elements using the pump rack. And that would continue forth and forth. Now, lastly, we would like to look at the advantages and limitations. You say the advantages that one, it's simple in design, it is low cost, and has really easy maintenance. Its limitations, it is less precise than, of course, electronic governors, and it may be affected by air leaks. If at all the intake manifold has punctures or has gaskets that are leaking, and then it can only work very well with small and medium sized engines. Common applications you'll find being used in agricultural diesel engines, portable generators, small construction equipment, and older stationary engines are making use of this. To maintain it, it is good that we make sure that we check the unit regularly for air leaks. The diaphragm should be inspected regularly, and we ensure that the linkages move freely. And of course, any adjustment should be made according to the manufacturer. Yeah, and that's pretty much it. Thank you for your time, and see you next time.